Hello everyone, this is Ashmita and welcome back to Civil Center. So, in our today's video, we will proceed to RCC. In the previous video, we have completed the PCC section. So, let us move now. So, I'm just sharing my screen. So, friends, what is RCC? So, RCC is basically reinforced cement concrete. So, here we add. So guys, RCC is basically reinforced cement concrete in which we add cement concrete with the cement concrete with the steel bars. So let us move. So for reinforcement, we have for reinforcement, we will do at first this portion, this pile portion. We'll have to do RCC first here, then after we will do RCC here in the bulb section. You can see. And then we will proceed to the foundation, and likewise we will proceed to the columns and the plinth beams and so on. So let's get started with the pipe. So as you can see here, we have this is our pile. So this is in cylindrical shape. So we'll have calculate the cylindrical shape of the pile, and after that we'll calculate this bulb section. So let us just calculate the pile section first. So in this pile section, first we'll have to write the numbers. So as we know, in the previous item we have done the piling work of 37 numbers. So simply we'll write here in the pile numbers, we'll simply write here 37 numbers, and for this length. So how we will find this length? We know this is in cylindrical shape. So if we will apply here cylindrical formula, so we'll get the length of the area. So our cylindrical formula is pi t square by 4. So here you can see this is the diameter. From here we can get the diameter, which is 250. So let us just calculate, is equal to, we'll write pi so then pi, and we close this into d square, which is 0.25, and then we close and by 4. So here we get the area of this cylindrical shape, this pile. So next we will write the height of this pile. So if we will write here the height of this pile, so we'll get the quantity. We'll just merge it as we have length and breadth in areas. So in the section of height, we'll just write 6. But friend, one thing you can see, this is our bulb section. So if we calculate this length in the cylindrical shape, which is in cylindrical shape here, so we can get. So friend, you can see here, if we will take this whole height, which is 6 meter, so this area will be get doubled, will be calculated doubled. So guys, as we know, the cylindrical height is 6 meter of pile, but we will have to calculate this area also. This is our bulb section. So if we will calculate bulb section also and pile section also, so this area will be, so this area will get doubled. So we'll have to just deduct this section, and also this is our, from this height after PCC, it has given 6 meter. So we have considered 70 mm of 75 mm of PCC and 100 mm of sand filling. So we'll just add 75 and 100 into the 6 meter. So if we'll add 6 meter plus 0.1 of sand filling and plus 0.075 of 7 PCC. So this will be our total length of that pipe. So after getting this length, we will have to deduct the amount of bulb section. So how we will deduct that section? We'll just simply go to the structural drawing, and you can see this height from this to this is our 250. This height is 250. So here is also the same section, which is in Frustum's. Here you can see in this bulb, we have 2 frustum. You can see 2 frustum and 1 cylindrical shape. So if we will minus this and this with the total height, so we'll get the actual height of the pipe. So here it is given 250, and in the bottom also it is given 250. For middle section, you can see this height is 150. So we'll add all these heights so that you can get this particular height. So 6.15, 6.175, you can just deduct that amount here directly. Minus 250 plus 250 and 150. So 250, 250, 500 plus 150, that will be our 650. So for 650, we'll convert it into meters, so we'll get 0.65. So this is our actual height that we need for piling after deducting the bulb section. After that, we can simply calculate the quantity. For quantity, we just calculate. For calculating the quantity, we'll just multiply numbers into this section into this section. So this is our quantity, and the unit will be in cubic meter. So for wall part 1, we'll simply write one numbers in the number section. So after that, you can see for wall part 1, we'll take this portion as part 1 and this portion in the part 2 section. So how can we have so how we can get this section? You can see here the diameter is 750, so we can just simply put the cylindrical formula. So here we can you can see we have the bulk part 1, which is the mid section. Here you can see this section. We get this area, we get this area. So after that we need the height. So you can see here 150. It is given the height. So we just simply write here the height. 150 was in mm, so we can write it in meter. So 0.15. So for this quantity also, we can simply drag this. Yes, we have get the correct quantity. So next, its unit also, it will be in cubic meter. Next is our wall part 2. So let us see what is our wall part 2. So as you can see, this is in the shape of first term. So this is our wall part 2. We'll calculate this area and this area. So let us just calculate it. So in number section, we'll write simply number 1, and then we'll put here the formula of Frustum so that we can get the area and height of the Frustum. So the formula of Frustum is pi into h by 12 into d1 plus d2 plus d1 into d2. So we can just write here is equal to we'll give the bracket and pi and bracket into h. You can see here this is the height. This is the height of the frustum. So we'll write in that section 250, which will be 0.25, 0.25. Then divide by 12 plus d1. So let us see what is d1, d2 here. So this section, this area, this will be our d1, and this bottom part will be our d2. Let me just so it's not perfect, but likewise, so this figure is something. So this figure is somehow like this figure. So this will be this top part will be our D1 and this part will be our D2 and this will be our total height from this to this. This will be our total height. So this how we can get this and how we can get this. Here it is given the bottom is smaller portion is 250 and the bigger portion is 750. So we can simply write in the section of D1 250 and in the portion of D2 we can write 750. So 0.25 plus 0.75 plus 0.25 into 0.75. So now we get the this total section that we needed, this total section. So already we have calculated the height also here. So we don't need here height. So simply we'll just calculate the number into this. So we'll get the quantity and by unit also we can write here cubic meter. And for pile depth, we have F1, F2, F3, F4. So we can simply copy from the upper section. We know we have already calculated the numbers and this length. So we can just simply copy from here the length and numbers and we'll paste here. So we'll copy this F1, F2, F3, F4. We'll copy it and we'll paste here. So now we want the inner portion of the pile. You can see here. We want this section. In this section, we want to do the RCC because this we have provided for the shuttering. So how we have already I think calculated the inner portion. So let us just see. Okay, so we have not taken the inner portion, so we'll take it. So simply we can select this and align it. So we can just simply select it and align it. So we get the area which is 0.66 meter. So we can just simply write it as 0.66 meter. For F1 we get 0.66 meter and now we will calculate the area for F2. So let us just with the same method we can do. Here you can see 1.14. So in the F2 section, we can write simply 1.14. So we have seen that F1 is similar to F4 and F2 is similar to F3. So we can just simply copy this in the section of F3 and for F4, we can copy from F1. So we get the area. Now we want height of this footing. So how can we find the height? So we'll just move to the structural drawing and you can see here in the footing section, the height is given for F1 is 350 and for F1, F2, F3, sorry, for F1, F3 and F4. These are similar, and only F2 it is given 400. So for F2 it is given 400, so 0.40, and all the rest are 350, so 0.35. So now we can calculate the quantity as we have the area, numbers, and height. So we can just calculate it. Or you can simply drag this one also. Then also you'll get the correct multiplication. So we have got all the quantities. Yes, we have got all the quantities, and for unit we know it will be in cubic meter as we have length, breadth, height. So next is our column part up to substructure. So here we will calculate the column up to substructure. We will not calculate the quantity up to substructure. So we will calculate the quantity of column. So we have 5 types of column. We can see C1, C2, C3, C4, and C5. So let us just calculate the quantity. So let us just calculate the quantity of columns. So for calculating the quantity of column, we need numbers, length, breadth, and height. So let us just see how many numbers of C1 we have. So we'll move to our structural drawing, and we can see here, you can see here, we have C1. We want C1, so these are C3, these are C4, C4, C5, C4, C5. We have only one of C1, only one column of C1. So in numbers, we'll simply write 1. And for C2, we'll have to move again for structural drawing. Now we can see, we let us just first count this C3. So 1, 2, 3, 4, 5, 6, 7. So we have 7 numbers of C3. So in C3 section, we can write 7 numbers, and after that, C3 we have completed, and 1, 2, 3, 4, 4 numbers of C4. So we can write here 4 numbers of C4. And we have left with C2 and C5. Let us just see how many numbers of C2 and C5 we have. So C2. So you can see here only one C2 we have, and for C5 we have 1, 2, so we have 2 numbers of C5 and 1 numbers of C2 and 2 numbers of C5. So after getting, so after getting the numbers, we need now the length and breadth of these columns. So we'll move to the structural drawing, and we can see here. Here we have the sizes of all the columns. So we can simply write it. So you can see 350 into 250, 350 into 250. and 250 to 350. Almost we have similar, only C3 we have 250 to 250. So let us just write C1, C2, 300 into 250. So we can write here 300, which is 0.30. In the D section, we can write 0.25, which is 250. And we have C2 also, 300 into 250. And C4 to C4 and C5, 250 into, sorry, C4, 250 into 300. We have two here in C5, 250 into 350. So now we will write C2 and C4. So for C2, we can write 0.25, and for C4, we can write 0.25. And in C3 section, for C3, 250 into 250, and C5, 250 to 350. So 0.25 into 0.25 and 0.25 into 0.3. Let us just check it. Okay. So now for height, we have taken, now for height, our floor to floor height is 10 feet 6 inch. So for 10 feet 6 inch first floor and second floor, for second floor also we have 10 feet 6 inch. So with the 10 feet 6 inch, the 10 feet 6 inch we have from this side, but we'll have to add this length also below plinth level. So we'll add 1.2 meter, which will be 1. We have 1200 mm, so which will be 1.2 meter, and in this we will have to deduct this section because we have already calculated. And also we have to deduct this plinth beam section. As we will already calculate, we can see we can calculate plinth beam, and we have already calculated the footings. So here so we know our floor height is 10 feet 6 inch, which will be in meter 3.2 approximately 3.2 meter. So in this 3.2, we I have said that we will have to add this height. So we'll add this height. So in this we'll add 1.2. We get 4.4. So in 4.4, we'll just deduct this height and our plinth beam height. So how can we get the plinth beam heights? You can see here we have this. This is the base and this is the height. So 0.30. So here 0.35 plus 0.30. You can take it in a bracket and enter. So this is our floor height, actual floor height for the concreting RCC. So we can simply drag it for all the columns, as we know, all the columns, the height of all the columns is similar. So now we'll calculate the quantity. We know for calculating the quantity, we can just simply multiply the numbers into length into breadth into height. So you can just simply drag it and check it once how the calculation has been done. It is correct or not. So it is correct. So these are the quantity of column reinforcement, and for unit we can simply copy this and we can drag it. Okay, so now we have plinth beam. So for plinth beam, we can write here in number section 1. I think we have calculated the area, sorry, the numbers of the plinth beam. So I think it is in sand filling. So yes, here you can see this is our plinth beam. Plinth beam. So we can just simply copy this amount in the portion of length. So we need this, and we get the length of these beams that will show you. Already in sand filling we have discussed that how we can get this length. So we want this length from center to center. So we can just simply so you can see this here the length are given from center to center. So we want it up to this section. If you, let us assume if you are taking this beam. So you can see center to center it is given, but we have already taken this outer area. So if we will take here again center to center, so it will get doubled. So it will have to again minus, we will have to do minus. So with this area, we can just, we know this is our 10-inch wall, and we have provided 10 inch. So we can just deduct 10 inch is our 250. When we will do it half, so 1 point, so 125 mm it will be. So 0.125, sorry, 0.0125. So it will plus it. Okay, 348. Let us just do it in our Excel sheet. 3481. So the length is our 3481, which is in mm. So 3.481, which is our center to center. So if you will divide this 10 inch into 2, so you'll get 0.125. So 0.125 plus 0.125. So we have 0.25. Simply you can just minus it 0.25 with the length, and you can get the exact length. So likewise, you'll have to calculate all these internal beams as we have calculated for the sand filling. So you can just calculate these internal beams likewise. So I'm not calculating for all the lengths. So we get the length. So now we want the breadth and we want the height. So for length and breadth, so for breadth and height, let us move to the structural drawing we can see here the length and breadth provided, which is 250 into 300. So let us just write down, and that's 0.25 into 300, which is 0.30 in meter. So we can just calculate the quantity numbers into length into breadth into height. So we get the quantity, and for unit we can just simply copy this. So now we'll come to the roof beam. So here you can see we have three types of roof beam. Let us just see in our structural drawing how many types of roof beam we have. This is our roof beam. So we have B1, B2 and B3. So CB, you can see CB is here in the outer portion. So we'll have to just calculate the roof beam which is inside this area. So we have B1, B2 and B3. The sizes of B1, B2, B3 is also given, which is 250 into 350, 250 into 350, 250 into 300. So in the B1 section, let us just write in numbers 1, and in length we can just calculate as we have calculated for Plinth beam. Okay, so for roof beam, we have to calculate the length individually because we have different types of length of Plinth beam and roof beam. So as you can see, this will not include. So here it is included. So we have to calculate once more. So in the same way, we can calculate this. And also for Plinth beam, we have the outer section of the same size. So for this, we'll have to calculate this length individually. So we'll calculate in our next video. So till then, thank you and have a nice day. We'll meet our next video. So we will meet in our next video.